So now, the brief review, we're going to take a look at some of the questions that came from the review for exam test 3. So, take a look at question number 8. We're given a function. We're given an interval, x equals -2 to 5. We want values of c that do the mean value theorem. So what the mean value theorem is that somewhere that if we find the average rate of change going from x equals -2 to x equals 5, that somewhere on this function, the derivative, the slope of the tangent line at some point c, x equals c, there it will equal the average rate of change. Okay, so to kind of make this evident, let's kind of do all of that graphically. So we'll graph this 4 minus 6x squared. Y equals, let's clear this out, 4 minus 6x squared. Now there is a way you can kind of limit the domain here. We're just going to go ahead and show the whole thing, and what we'll do to the easy way is to let the window only go from -2, x equals -2 to 5. So we're only going to see from -2 to 5. Let's go from maybe -20 to +20. I think that should be enough. Well, I'm not really sure, but at least we'll have our domain in there. We'll look at the graph from -2, and we're fine, pretty much. Right? Well, actually, maybe we got to go lower, right? Here's x at -2. Looks like we can see that. It goes up, and then it's going to come down. So it looks like to get our window to work, maybe we need to go to like -100. My guess, maybe bigger. I guess I could look at the table. Yeah, we need to go bigger. One way to do it is if we view our table, let's just go to table set actually. Let's start it at -2. And we're going to go up by ones. Oops. Let's come on. We'll go from -2. We'll start at -2. We'll go to the table, and we see from -2 up to 5. 5 is at -140. We're going to need these values anyway, so 5, we got the point at 5 is going to be -146. Even for an open answer, you know, for showing your work, you don't have to show the arithmetic between this, you know, but just show that you've got these points. Okay, so one thing we're going to do is the mean value theorem is we're going to get the average rate of change from -2 to 5. So that means you take the y values in the top, subtract them, and you take the x values in the bottom and subtract them. -2. From -2 to 5. So this is going to give us -146, minus -20. Actually, that becomes plus. So this becomes -126 in the top. Negative positive becomes 7 at the bottom. So this is our average rate of change. And what we need to do is we're going to find some place along here where the derivative is equal to that. And again, we're going to look at some, I guess we go ahead and plug it in, derivative at some point c. The derivative here, derivative of 4 is 0. Derivative of this part is going to be 2 times -6 is going to be -12x. So there's going to be some place where this is equal to -126 over 7. Just solve for x. Actually, I guess we could, you know, let's see, right? Plug in, because we're finding it at a particular point. So we just divide both sides by negative 12. Or that's the same thing as multiplying by 1/12, right? That's negative 1/12, 12 dividing by 12. So negative negative is going to be positive. C is going to be a positive value. Um, and remember, C is an x value, so it has to be in this interval. And let's see, 126 divided by 12. It's not going to go evenly, is it? Of course not. I don't think so. But probably, yeah, 10.5 over 7. It's going to happen at 1.5. Okay, that's an exact value. It's not a repeating decimal. And so what we'll do is we'll actually plug that in. What's negative 126 over 7? So negative 126 divided by 7 is negative 18. I wouldn't have guessed that. So when we go look at our table, I'm going to change our table set a little bit. I'm going to have it go by 0.5 instead of by ones. Okay, and then we'll go to our table and look what happens when we get to 1.5. Oops, not 1.5, 1.7. How did I? Maybe I'm going too fast. Answer divided by 7 is 1.5, and I wrote 1.7. See. Let's try this. So 126 divided by 12 is 10.5. 10.5 divided by 7, that's what we got here, should be 1.5. Sorry, folks, but I guess you get to see all my errors along with negative, negative. So at 1.5, we should be equal. Oh, we plug in 1.5. The function value is not equal. Okay, that's where I'm getting off. It's not that the function value at 1.5 is equal to this average rate of change. It's that the derivative at 1.5 and the derivative at 1.5 is negative 12 times 1.5. So the way, which is negative 18, okay, the way we're going to see this, I'm thinking through this as we go, is we're going to look at the graph, right? What we're going to do is we're going to get the tangent line. So we're actually going to do a draw, right? Second draw. We want to draw the tangent line at 1.5. Thank you very much. I think we're supposed to enter it, right? 1.5. It'll draw it, and it'll give us that it does have its slope of the tangent line is negative 18. And that's what the average rate of change is. And if we were to draw that in from here, well, I guess we have to go down a little bit further to where we have 5. We would see that those lines are parallel. So that's what the mean value theorem says. Bottom line, we get C equal 1.5. So I'll keep moving on. I know we need to do that, but that's how we do it. Find the derivative there. Okay. And we got a few questions to go through, so let's keep moving. So we've got a function here at 2x to the 6 minus 7x to the 5th. We want to indicate where it is concave up and concave down. Justify your answer with the second derivative. So, and then it asks what are the x values for the point of inflection. So that's kind of, by using the second derivative, that's what we'll figure out. Basically, we'll find where the second derivative is positive, sorry, where it is equal to 0, and then we'll look to the left and look to the right. And because where the second derivative is 0, that's where we get inflection points, or potentially. We could also get something else, but so let's do this. First derivative is going to be 12x to the fifth minus 35x to the fourth. Second derivative, 5 times 12 is 60, and then it's x to the fourth. Remember, subtracting 1. 4 times 35, just don't want to think right now. I'm going to try to do multiplication in my head. 5 times is 140. Okay. And then that's x to the third. So that's our second derivative. This is what we're looking at. We want to set this equal to 0. And to solve this, we'll do a factored form. We can see you get x to the third factored out. 60 and 40, certainly we get a 10 out of there. We can get 20 out of here. So 20 x to the third. Take 20 out of 60, what will be left is 3x. Take 20 out of here, you'll have a 7. So we get two solutions. 20x to the third equals 0, so that means that x equals 0 is one place where the second derivative is 0. The other place is when 3x minus 7 is equal to 0. Add 7 to both sides, you get 3x equals 7. Divide both sides by 3, you get x equals 7/3. So two places where we're going to have inflection points. What are the x values for the points of inflection? Well, we found that first, actually, and 7/3 is a little bit bigger than 2, 2 1/3, right? So what we have to do is look in between them and what are the signs, what are the sign values of the second derivative. So if the second derivative is positive, we get a smile, concave up. If the second derivative is negative, we get a frown, concave down. Kind of rhymed. Mathematical poetry, right? So we can use the point -1 here. We can use the point +1 here. And then to check over to see what's happening over on this side. This is a little bit bigger than 2, right? It's 2 1/3, so we could check at 3. So we're going to check these points. So if I put in -1, this is going to become positive, right? Positive 60. So second derivative at -1. Again, we're not so much worried about the actual amount, just whether it's positive or negative. So we get 60, but sometimes we have to do this, right? A negative on the 3, so when it's going to become a negative times a negative is positive, and that's where I'm going to stop. All of this is positive. So what I know is the second derivative is positive on this interval, so from -infinity to 0 is concave up. Let's get rid of all this other stuff, I guess. Give ourselves some more room. So what we know at this point is that concave up from -infinity until 0. Remember, at 0, it's an inflection point, so it's sort of either concave up or down. It's where it's going to change. It's a turning point. We're going to assume that when we put in 1, we're going to get a negative, and you can kind of see 1, this is going to be 60. So second derivative at +1. Let's just emphasize the +1. We're going to get 60 here. We're going to get -140 here, because that's, yeah. And so it's going to be negative, and you have to check all these points, but it's all going to be negative. So that's going to be concave down. So this is up, this is down. It's going to happen until these, so these are our inflection points, 0 and 7/3. So it's going to be concave down from 0 to 7/3. And then I'm going to guess that when we plug in 3, we're going to be concave up. I'm going to just kind of jump ahead and say that that's what it's going to be. If I put in 3 here, that's going to be 3 to the 4th. It's going to be a big number at times 60, and then 3 to the 3rd. Well, we're getting big numbers, but let's go ahead. 60, 3 to the 4th, minus 140, 3 to the 3rd. What is 3 to the 4th is 81, plus times 60. That's 4,860. I bet you that's bigger than when we get 3 to the 3rd is 27, right? Times 140. That's 3. So it's smaller. This is positive, just as I mentioned. Okay, so that's all we need to know. And so that what that tells us is that from 7/3 to infinity, because these are our two turning points, our two places where the concavity changes, positive, it's going to be concave up. And then inflection points, x equals 0, x equals 7/3. So there's that connection. When we know our inflection points, we can definitely, we need our inflection points to find really our concavity. And we get that all from the second derivative. Find where the second derivative is equal to 0, and then look to the left, look to the right. And if we've got change in concavity, plus or change in sign, then that means, yes, this was an inflection point because concavity is changing on either side. So those are all tied together. Okay, I'm going to keep on moving through. We've got 4 more to do, so let's just kind of keep going and bust our way through this. I know maybe you don't have questions on all of these, or maybe you don't have to look them, so you can fast forward if you understand these ones. A rectangle is described in the base with its base on the x-axis and its upper corners on the parabola. Y equals 8 minus x squared. What are the dimensions of such a rectangle with the greatest possible area? Okay, a rectangle is inscribed with its base on the x-axis and its upper corners on this parabola. What are the dimensions of such a rectangle? So let's first do a quick graph of this. It's a negative, so it's going to be an upside down parabola, and but we can kind of take a look at what's going on. Let's clear this. So 8 minus x squared. I'm going to do a zoom standard because I think that'll fit it in just fine. So zoom 6. We go up, we come down. So the x-axis. So we're getting some kind of a rectangle in here. And we can see we can, if we come out too far, it's a kind of a narrow, I guess I could draw it over here. So we get something, so what we're looking at is this. We could get, if we go from here to here, there's one rectangle, but I think something like this would give us more area. We go up too high, we get, again, a real thin little rectangle. So we're kind of figuring it's going to be somewhere in between here. You know, that looks like that one has the best. Where the dimensions of such a rectangle with the greatest possible area. So um, what we want to think about is how do we get the area of this rectangle? Well, the area of the rectangle is length times width, base times height. Let's go with base times height. Well, how do we calculate the height of this rectangle? Well, it's going from whatever this x value is here to this y value here. So the y value really is the height, the y value. So the height is going to be determined by 8 minus x squared. What is the base of the rectangle? Well, this is negative x because it's kind of looking, it's going to be symmetric, right? So this goes from minus x to plus x. How do we get that distance? It's the distance between here, thinking of it as positive, we're going from x, you subtract the lower one, so whatever x is, we're going between x and negative x. Notice this is x and that x, so the base is going to be 2x. And that will give us our area. What we want to do is we want to maximize this area. And so if we take the derivative and set it equal to 0, we'll get either a maximum or a minimum. And we'll see what happens. So we're going to take this one. Let's go ahead and distribute this 2x through. So 2 times 8 is 16x. 2x times negative, this becomes negative 2x to the third. We want to max, this is not, well, yeah, that's area. We want to maximize the area, so we take its derivative, right? The derivative of the area is going to be, derivative of 16x is 16. Derivative of negative 2x to the third, the 3 comes down, we get negative 6x squared. We set this equal to 0 because we want to, that will give us either a maximum or minimum. We know in this case it's also a parabola, so it's going to give us a maximum. Let's see, we could factor out a 2. That gives us, take the 2 out, that's 8 minus 3x. Guess we could have done that up there, just leave that out, just go through. Anyway, 3x squared. Divide both sides by 2, so we just really need to find where 8 minus 3x. And that's really what we're looking at as a vertex. If you remember, it's going to be minus b over 2a. And that's exactly what we get, isn't it? So you subtract 8 from both sides, you're going to get negative 3x squared equals negative 8. Right, subtracting 8 from both sides, divide by negative 3. We get that x squared is equal to, what are the dimensions of a rectangle? Okay, negative x squared, so x squared is equal to 8/3, right? Dividing by negative 3, the negative become positive. And then you could take the square root of both sides, so x really needs to be the square root of 8/3. Guess you could take a 4 out, right? Square root of 4 is 2 if you wanted to. 2 square root of 2/3. And that 3 is also, it's inside the radical. So what would the dimensions be? Well, the dimensions of the rectangle, the base would be 2 times x. So 2 times this. yourself a little bit more room here. Come down to the next page. Spill over a little bit. Okay, so the base equals 2 times 2 square root of 2/3. And the height, well, we plug this into the function 8 minus x squared. So you're going to get 8 minus 2 square root of 2/3 squared. It's going to be 8. When you square this, you're going to get 4 here. The square root comes off here. 4 times 2 is going to be 8/3. Comes back. Makes sense. We had square root of 8/3 there. Just got to think of it that way. And 8/3, so get a common denominator. 3 and multiply the top and bottom by 3. That's going to give you 24/3 minus 8/3. 24 minus 8 is 16. So 16/3. That's its height. Base and height. And if you wanted to, you could also plug this back in to this area formula and find out what that area is, but they didn't ask that. They only asked for the dimensions. And that will give us, and we're kind of assuming, yes, it's going to give us, because anyway, kind of know that a square root that has a negative on the squared part, that's a parabola that goes concave, that's concave down. That gives us a maximum. All right, a couple more. Let's keep on going here. I hope you're finding all this helpful. And again, fast forward through the parts that you don't need. Maybe it's good to kind of, or do it at like double speed, and then it kind of at least will refresh you. Find the particular antiderivative that satisfies the following conditions. So since this is a second derivative, we're going to have to do antiderivative twice. And remember, we do an antiderivative, we get a plus c, and at each step, what we're going to need to do is plug in these values to figure out what c is for each of those steps. Okay, so first, what is the antiderivative of f double prime? Well, that would be f prime. Right, so we're finding the derivative before the second derivative. So we're sort of doing this integrating. So we're going to add 1 to the exponent and then divide by that new exponent. So we end up with 8x squared divided by 2. If I'm just more careful at the beginning, which is going to be 4x squared, but we'll clean that up in just a moment because we've got a lot to do. How do I get so that the derivative is sine? Well, that must have came from a cosine. So we'd have 2 cosine. But if I take the derivative of cosine, I'm going to get negative sine, right? And I've got a plus sign, so I must have to have started with a negative, so that when I take this derivative of cosine x, the negative will become positive. And then I get plus a constant. The way to figure out what this constant is we're told that when we plug in 0 for x into the derivative, we get 3. So then what we're going to do as we clean this up, we're going to f of 0 is equal to 3. 8 divided by 2 is 4. So 4, 0 to the squared. 0 squared. That's good. That's all 0. Minus 2 cosine of 0 plus the constant. Now cosine of 0 is 1, so that gives us that 3 equals negative 2 times 1 plus c. Add 2 to both sides, and you get 5. That c is equal to 5. Okay. So what does that mean? It means that our actual, the specific antiderivative, the first antiderivative 2, is going to be this function 4x squared minus 2 cosine x, not just plus c, but plus 5. Well, I said 5 equals 5 here. Sorry, folks. Add 2 to both sides. 5 is equal to c. Okay, so we've got that. Now we do the same process again. So what's the antiderivative of the first derivative? Well, that would be our f of x. That's what we're looking for. Again, add 1 to the exponent. That's going to give us 3, and divide by that new exponent. So that's going to be 4x to the third divided by 3. Cosine, how do we get a cosine? We take the derivative of sine. So this is now going to be 2 sine of x. When we take the derivative of sine, we get positive cosine, so we have to leave this negative. We have to check on that. When we integrate or get the antiderivative of 5, that's going to give us 5x plus a constant. And then what we do is we take our information here to figure out what that constant is, that when x equals 0, y is going to be 2. Let's give some more room here. Move up a bit. So we're going to say, to find out what c is, we know that f of 0 equals 2. Plug in 0 here, this is going to be 0. Plug in 0 here, this is going to be 0. Sine of 0 is 0. Plug in 0 here, this is going to be 0. So c is equal to 2. So that was kind of a nice, easy one. But it's not, if this had been cosine, then it would have been something else. So anyway, that's what we have to do. Plug in the 0. We got c equals 0. So it's this whole thing. But what we do, I'm going to cheat a little bit. I'm going to say, because you could watch the video, then go backwards. This is equal to 2. Okay, so that's our final answer. That's what the specific one is. Not just a general antiderivative, but the specific one with that information. Okay, a couple more. Almost there. Yeah, let's just do a new page. And this one. I don't know how much. Okay. So, 27. Let's come back here. Particle moves on a straight line. We've got acceleration at its position, and we've got its velocity at a particular time. What's its position at time t6? So position, remember, this is basically the same as this last question we did. This is like a second derivative of the position function. So what we have to do is we have to backstep 2. We have to take 2 antiderivatives, and then we can figure it out from the information we're given. These pieces of information, just like the last one, they allow us to figure out the values of c as we go through, and so forth. So we start off with the acceleration. So the first antiderivative is velocity. So velocity, we'll just do in general, I guess we'll use t. So add 1 to the exponent, so that this is t to the 1, so that's going to be t squared. So I just like to go ahead and do it this way, 36 t squared divided by the new exponent, and again that will reduce, plus 10t, because if the antiderivative of 10 of a constant is be this, plus a constant, right? But they tell us when when t is 0, we have t 0, that the whole function has to equal 9. So this is v of 0. I'll just kind of, so if t is 0, this is 0. T is 0, this is 0. So you get 0 plus c. So you get that c equals 9. So again, we just kind of take a shortcut and say, okay, yes, that's all. Let's not have to write a bunch of stuff out. I'm just going to get rid of all of this. This equals 9. Now again, if this is an open answer, I would want to leave those things and I'd have a whole sheet of paper. I just don't want to keep, right now, rewriting things. Okay. What we can do though, 36 divided by 2 is 18, so let's clean that up a little bit. I think that'll help. So this is our velocity function. The next thing we want is our position function. Usually they use s. And again, that's going to be an antiderivative because the velocity is, right, this is the derivative of the position function. If I take this, I get velocity. And acceleration is the derivative of velocity. Okay, so antiderivative. So we add 1 to the exponent. We're going to get t to the third. And then we divide by that new exponent. 18 divided by 3 is 6. Okay. Take t, add 1 to the exponent. We're going to get 2. Divide by that new exponent. 9t, when you get the antiderivative, plus a constant. And again, we see the, because this is a polynomial, when at time 0, we're equal to 8, right? And so if you put in 0 for t, just like last time, when s of 0 is going to be equal to 8, so 0, 0, 0, c has to be 8. Okay, so we see that same sort of thing happening because we got a polynomial. So let's, again, save ourselves a little space. And you'll see why I don't like t's. My t's often look like a plus sign, but so that's the function we have. And then now they ask us when t is 6, what is the position? Well, we just plug in 6 for t and it will now get its position. Give a little bit more room. And we'll kind of clean up as we go here. Okay, so 18 divided by 3 is 6. T is also 6. Cubed here, so I'm plugging in. I'm finding s of 6 now. This 10 divided by 2 is 5, so we'll put that there. We plug in 6 for t, square it. 9 times 6 plus 8. So now this is just arithmetic. We can go ahead and just plug it all in, clear this stuff out. So what do we have? 6 to the third. 6 times 6 to the third. And again, just be careful here as you do things. Just because you're plugging in the calculator, see, I tell you to be careful. And 6 times 6 to the third, arrow down, plus 5 times 6 squared, arrow down, plus 1 times 9 times 6. My writing is terrible. Plus 9 times, that's what, 56. But again, sometimes you just want to go ahead and do this because sometimes, at least this is my thing, sometimes I get the simple arithmetic incorrect, and writing throws me off. I thought that was a 1. It's a 9. And then we've got a plus 8. So 1,538. Yeah, so 1,538. That's its position. It's on a straight line. That just kind of tells us where we're located. All right, I think this will be the last one for, let's see, yeah, and then we get into that other review. So for this video, we'll just do this one. Estimate the area under the graph of here from x equals -1 to 5 using 12 rectangles by finding left-hand approximation and a right-hand approximation. So it's just kind of some practice. So do I still have that program? I do, Riemann. So let me just show you this using the Riemann. If you have this on your calculator, sure, you could go ahead and use it. So let's go ahead and do it this way, and then I'll do it the other way. So it asks for the function for x to the third plus 5. So we'll enter that. The lower bound, -1. The upper bound, 5. And then the partitions are 12. Just like that. Now remember, it's going to give not only just give us the answer, but it'll draw the graph for us. It usually finds a good. So it's showing us we're going from -1. There's probably a little line there somewhere to 5, and then we're going to hit enter. And we want our left hand. That's the first thing they ask for, left sum. Now it draws all the rectangles, and we can see we're getting left-handed ones. So the left hand has a sum of 534. Now, if this was multiple choice, this is all we have to do. We want to get the right-hand one. We hit enter, and then we could get the right sum. Again, it draws it there, and we see that we're getting the right intervals, and you can see the last one's going to be there, 786. And just while we're at this, it's probably, if we basically add this together, the most accurate answer is probably about halfway between this, right? Add them together, divide by 2, that gets you an average, which should be fairly close to the midpoint sum. That's generally the best one we're going to get. There's the midpoint sum of 654, about halfway between there. That's the best approximation, but they didn't ask for that. If you don't have the Riemann sums, how would you go about doing this? Well, you've got to do 12. So you've got to, but it's okay. We're going from -1 to 5. So notice that's 6, a length of 6. Right? What you do is you go the larger side minus the smaller one. That's a difference of 6. Take 6 divided by 12. And what that gives us is that each interval should have a base of 0.5. Okay, so thinking of this, here's -1. We want to go -0.5, 0, and then here's 1. But every 0.5, we're going to have a rectangle going up, and we'll either do a right or a left rectangle, and it's going to look like this, something, right? Whatever, left and right, and we don't mix them. So the first one, if we're doing a left hand, so we start at -1, we're going to want f of -1 plus times 0.5, right? Because that's going to be its height. Actually, instead of writing it, every one, the base is 0.5, so I could factor that out. We take the height times the base. So I factor out. We want f1, we want f of minus 0.5. We're going to want 12 of these. It's kind of tedious. Hopefully on the exam they they won't ask when it's 12. Maybe it was 6, but anyway, this gets you. So negative 0.5, what would be the next? We're going by half. That would give us to 0 plus f of 0.5 plus f of 1. And basically, we're going to keep going all the way to what's the last one? It's going to be f of 4.5. We don't go to 5 because we're only going to get 12 of these. So if you don't have this program, what you do is you just, oh, we can't quit. We got to go here and then 7. Now we're quitting. We're going to enter the equation. Oh, we've already got this. Maybe we used it for something else. 4x cubed plus 5. And then what we're going to do is we're going to table set. We're going to start at negative 1, right, because that's the lower bound. We're going to have it change by 0.5 because that's what we figured out is the basis has to be there. And then when we go to the table, right, it's going to give us all our values, and we just take the first 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not giving us values. What did I do? Oh, I got it turned off. How did I do that? Oops. Y equals enter. Now I got to turn it back on. And then when I go to my table, I'll get these values. Okay. And the last one down there. So there's 11, and then 4.5 would be number 5. So it's going to be 0.5 times 1 plus 4.5. So I'm getting these from right here. These are the y values. Plus 5. These are the heights of these rectangles. This is the base of the rectangle of all of them, same amount. Plus 5.5 plus 9 plus 18.5. All right, by the time we're done, we'll end up with the 534 plus 37 plus 67.5 plus 113 plus 176 plus 261, and then I need 4.5. So I have to arrow down. Now I don't use 5, right? Because that's I'll use that only on the right-hand side, looking at those rectangles. But plus 389.5. So we're going to add all of these together, multiply by 0.5, and I'll just do that. This that's the one. Okay, so we get, just to show you the tediousness. I'm not going to do the second one. You can basically, you know what the answer is supposed to be, so you can match to that if you need to for practice. Plus 5 plus 5.5 plus 9 plus 18.5, 37 plus 67.5 plus 113. Okay. Do have them all here. 176.5 plus 261 plus 389.5. Enter that times 0.5, and we got 544. Did I miss something? 1, 4.5, 5, 5.5, 9. If you see something 113, 176.5, 261. I'm off by 10. We should have matched the same. We should have 534. And see. Oh, it's 369. Not, maybe I should put my glasses on. Okay, so that makes sense. 369. So that's 20 less. Let's come back here to calculation. So it's not 1088, 88, it would be 10 minus 20 from that. It's going to be 1068 times 0.5, 534. So I was just, we do need to match up. They should both be the same. Do the same thing with the right hand, except again, what you're going to do is on this, you go to the table and instead of starting at x equals 1, you're going to start at x equals negative 0.5. So you're going to take all of these and you're going to have the 1 for 5. So it's just basically all the other, the last 11 plus the last one gives you your 12. And you'd be able to get that. So that's using Riemann sums. Okay, do we have any? So good. We got to the end of this video. So keep it going. Good studies, and I'll make the last video all in